Welcome back. In our last lesson, we defined a custom function to calculate player scores, complete with parameters and return values, and we wired it up inside our main function to print the final result. Today, we are stepping into the core philosophy of Rust, compiler-driven engineering. We will explore how Rust handles variables differently than languages like JavaScript, and why this matters for building robust, enterprise-grade applications. Here we are in our editor, with a fresh slate, ready to start coding. Declare a function main, followed by empty parentheses, and open and close curly braces. This will serve as our entry point. Inside the main function, declare a variable player level using the let keyword, and set its value to 1. This establishes our initial game state. Type println followed by an exclamation mark and open and close parentheses. Next, we want to log our data to the console. Inside the macro, add a string literal starting level : followed by empty curly braces, and after the string, pass in the player level variable. This will output our initial state. Type player level equals 2, followed by a semicolon. I want to briefly point out that assigning a new value to player level is a statement, doing an action, which is exactly why we enforced the semicolon at the end. Now, let's print the new value of player level to the console using println. Inside the parentheses, add the string level up, exclamation mark, new level, : add curly braces, and pass in our player level variable. Now that our code is written, what do you think is the next logical step? If you guessed executing the code to see our player level up, you are on the right track. Let's see what the compiler has to say about this. Whoops, we got an error. It says, cannot assign twice to immutable variable player level. If you are coming from JavaScript, this mindset shift can be confusing. In JavaScript, const is locked and let is changeable. But in Rust, let is locked by default. The concept here is default immutable. Rust assumes you do not want data to change unless you explicitly ask for it. The compiler isn't trying to annoy you. It is acting as a safety net to prevent silent state bugs where data changes unexpectedly in large applications. On the line of code we just wrote, update the declaration to use let mut player level. By adding the mut keyword, we explicitly tell Rust that this value is allowed to change, which fixes our error. The mut keyword here used to declare that a variable is mutable, meaning its value can be changed or reassigned. When we run the code now, it executes successfully. By typing mut, you are creating a contract of intent. You are signaling to every other developer and the compiler that this specific piece of data will change over time. This provides massive enterprise predictability. If an architect looks at a 5,000-line Rust codebase and sees a standard let variable, they have mathematical certainty that no other function or background thread is secretly mutating that data behind their back. And that wraps up our deep dive into mutability and compiler-driven engineering. You've just taken a huge step in thinking like a Rust architect. In the next lesson, we will explore even more powerful features of the Rust language. Great job, and I will see you then.